Hello, Castle Hill scientists. It is another great day at school. The tortoises are all outside enjoying the sun, and I am ready to do this density tower project with you. Now, if you were able to get the materials to do this on your own, wonderful. But if not, well, that's what this whole video is for. I will ask that all of you follow along, and we're going to determine the density of each of our liquids using the table that I sent you on that separate document. You're going to need to list all the liquids, the total mass, and when I say total, I mean the beaker and the liquid. All right? I can't really just pour honey onto the scale balance and, that would be a mess. So we got to put it in a container, but then we need to subtract the mass of the beaker from the total mass, and that's going to give us the mass of the liquid. Now you'll see on your table that the mass of the beaker is 33.2 grams. And the volume of the liquid we're going to be measuring is 30. All right, so in order for us to find the density, we're going to divide the mass by the volume. So whatever number we get when we weigh the total mass, subtract the mass of the beaker, and divide that by 30, that's going to give us grams per milliliter. And then as you go along, I want you to, once we figure this all out, order the different liquids, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 being the most dense, 9 being the least dense. So I've got all my things here. I've measured everything out. Let's start measuring the mass. And now you all are going to need to do the calculations. A calculator will be very good to determine the density. I have my triple beam balance here that we're going to use to measure the mass of the beaker and the liquid. So you're going to need to record that and then do the following calculation to determine the density of each liquid. So let's start with milk. On it goes. Each of these things has a different mass. I slide it out till it drops. Not quite. All right, 70 is too heavy. So I'm going to bring it back to 60. 60 is too light. So I'm going to take this one here, which each one of these is in grams. So it goes up to 10. I'm getting warmer. Getting warmer. And then when the lines meet over here, then we know we have an accurate measurement. Okay, I'm going to buy this at a weight of 66.6. 66.6 for milk. All right, let's get on to the others. Milk, dish soap. Okay, dish soap isn't as heavy as the milk. All right, dish soap is coming in at 63.9. Let's do corn syrup. Clunk. 77, almost. Gonna bring it back. And we're gonna call that 76.6. Let's do corn oil. Okay, it's not as heavy as the corn syrup. Corn syrup is weighing in at a total mass of 60.5 grams. That's the beaker and the liquid, remember. This is isopropyl alcohol, and I added some dye to it. Oh, that's really light, huh? Let's bring this back to start with 50 grams. Okay, isopropyl alcohol is weighing in at 57.7 grams. 57.7 for the isopropyl alcohol. And let's do honey. Clunk. We're going to start with 70 for the honey. 77.6 actually. Okay, we're going to call honey 79.3 grams for the honey and the beaker. Let's do chocolate. Okay, looking a little lighter. We'll bring it back to 60. Okay, that is 70.7. 70.7 for our chocolate. Lamp oil, much lighter. We'll start at, okay, lamp oil is weighing in at 59.4. 59.4 for the lamp oil. And last but not least is water. I'm going to slide this back. That's too much. That's not enough. And that is just right. At a measurement of 65.4. Okay, so you've got all the measurements. Now do the calculations and order them. And that is your assignment. All right. But I said that we were going to build our density tower, so let's do it. Okay, let's get ready to build our density tower. Now, based on my calculations, I'm not going to tell you the exact density of each of the liquids, but honey was the most dense, corn syrup, chocolate syrup, milk, water, dish soap, corn oil, isopropyl alcohol, and the lamp oil. I hope I didn't spoil anybody's fun there. So we're going to start with the honey, and I'm going to pour it straight down the pipe. Okay, second up, corn syrup. Let's see, I got my corn syrup here. I'm going to just go ahead and pour it straight down the middle, trying to not go too fast. Corn syrup. All right, so I've got my corn syrup and my honey, and I got a little lamp here so you can see against this white background. And so everything is going as it should be. Now we're going to add our chocolate syrup. I'm gonna go ahead and add a little bit more so we get a nice tall column. Okie dokie. Now, the next three, milk, water, and soap. I found that the density of those three things was very similar. And I started to wonder, do I just want to go ahead and dump all those things in my density tower before I do an experiment with just those alone? So that's what we're going to do. I'm going to do a mini tower in here. So it calls for milk, water. I'm going to pour this in very slowly. I'm not really feeling it here. And then soap. the soap is staying on just barely on the top, but it's clumping all together. As we can see, it's gone down to the bottom. Okay. Well, that didn't work very well, did it? All right. So this is a great opportunity to use some of the knowledge we already know about how to increase the density of something so that maybe we can make this thing work with milk. So let's get a little more milk. And what did we use with the water to make it more dense? That's right. Get a little bit of salt. I'm going to mix my salt in with my water, or my milk. A little bit. Stir it around. Now, I know some of you have already done this and it was a disaster. Well, it's not a disaster. Doing an experiment is never a disaster. It's always a learning experience. And then we're going to apply what we learned the first time to what we do the second, third, fourth, and 10th time. Okay, now I really want to drip my water in slowly. So I'm going to use the straw method because I know that some of you don't have a turkey baster at home and I want to be united with you. And I'm going to use the big bottle of water and stick my straw in, clamp the top, put it right on the surface, and slowly let it drip in. Okay, well that worked a little better. You can see the milk is down at the bottom, pushing up the red water. Not as nice as I had hoped, but it does support that idea that when you add salt to something, it increases the density. And now we're going to try a little of the soap. Running it very slowly around the top, almost trying to make a raft. I'm having a little more success with this. Okay, the soap is staying on top. Need to get a little more soap. Okay, right, so that is not so bad, but I had to change the property of the milk by adding some sugar so it would be successful. And then the milk and the water still are, they're kind of clumped up a little bit. So as I move forward, I'm going to go ahead and add a little bit of salt to my milk that's going to go into our solution tower so we can get, maybe we can get a better defined layers. Now with my milk, I'm going to gently, very gently, or I should say my milk and salt solution, because we mix two things together and it looks the same throughout, which makes a solution. I'm going to very slowly drip it down the side. Well, there's no surprise there. Milk is much less dense than the chocolate syrup, so we would have expected that to happen. Now comes the tricky part. I'm going to go back to my straw and I'm going to do some of the same dripping, but this time I'm going to do it really, really slowly. I guess that wasn't as slow as it could have been. I think it's about as best I can do with that. But we do have some separation between the red water and the milk, with the salt included. Now the tricky part is going to be to get this soap into the very center of my graduated cylinder. I'm going to use my straw method again. And this time I'm going to use a new straw. Okay, I think that's about as good as I'm going to get. And I will not lie, this took me about 10 minutes. All right, on to our next liquid. So far we have our honey, corn syrup, chocolate, milk, red water, and green liquid, which is looking pretty yucky. Here's the one that I did just a little bit ago, just so we can see that it does, after it sets a little bit, you get a little more separation. But we got the dish soap on top, red water, mixed in with the milk at the bottom with the salt. Okay, so now we're on to corn oil. I'm feeling a little better about this because I saw that the density difference between the soap and the corn oil was pretty significant. So I'm just going to tilt it to the side and I'm going to drip my corn oil down into my graduated cylinder. And now we're on to isopropyl alcohol. And this is what I had before. I'm going to add a bit more just to make our density tower a little bigger. And again, this was pretty light, so I feel pretty good about just slowly pouring it down the side. Oh, much more gratifying. Much more. You can even see when you drop the lamp oil down and it bounces right up. And last but not least, we have our lamp oil. Got a very nice blue color. Now the density between the lamp oil and the isopropyl alcohol was pretty similar, but I think because the properties of these two things are very different, we're going to get a really nice layer here. Again, you can see the lamp oil drops down into the isopropyl alcohol, and then it jumps right back up. There's a little bit of mixing going on there, but if we wait a minute or two, that's going to have some nice separation to it. And there are a few little bubbles that are, there are little interaction there with the bubbles that are holding on to some of the isopropyl alcohol, which is then going up into the lamp oil. But as those bubbles pop, that layer becomes much more defined. All right, now that I have all of my liquids in my tower, let's drop a few things in and see what happens. First, I'm going to drop in a corn kernel. All right, I kind of lost it in the soap layer. All right. Let's try a bead. Ooh, it's sitting right on top of the soap layer. Let's do another one. Ooh, it's like sitting on a pillow. And let's see what happens when we drop a bean in. Oh, it seemed to go a little more slowly, but it's somewhere between the soap and the milk. Can't really see that one. Now, here is a nut. Where do you think this one's going to go? Right down to the very bottom, and it took some of that chocolate with it. Now the bottle cap, I'm going to float it right on top, just like that. And I'm going to slowly pour in some water. Well, it did indeed go down to the level of the water, or the soap, and stopped, but it capsized. Well, hopefully you'll have a little more luck with that. But I do notice that the water is staying on top of the soap this time. So that's kind of interesting. And last but not least, Ask you to drop a ping pong ball in, but my graduated cylinder is too narrow. So I'm going to take a styrofoam ball and it floats on top. I hope you have enjoyed this and didn't make too much of a mess. But if you did, remember, it's all in the name of science, so it's all good as long as you clean up. And I look forward to seeing your data sheets that you will send back on Google Classroom. Take care, everybody. Bye.